Hi there, looking at the 12 video in differentiation, looking at differentiating sine and cos, sine x and cos x. Okay, so just a wee nice quick video this one. We've been able to differentiate in terms of the form y equals a sine x, and being able to differentiate in terms of the form y equals b cos x. So just when we've got sine x and cos x, we're multiplying in front. Okay, to show you what's going on here, I'm going to look at the derived graph. Okay, just have a, so quickly, when you're looking at sine, you have a stationary point here. The first part's positive, then it's 0, negative all the way down here to 270 or 3 pi over 2, where it's 0 again, and then it's positive. Okay, so bringing that first stationary point down, you know that that's got to be a root on your derived graph. Okay, and then same at 270. So at pi over 2 are 90, and at 270 we have stationary points. Prior to that it's positive. Okay, so it's positive in there. In between the two stationary points is negative. Okay, and after that 270 it's positive again. Okay, now what that looks like when you do the derived graph is it looks like that. Okay, it doesn't, that's a bit messy. Okay, but I'm hoping you can see that if you do the derived graph for sine, you end up with a graph that looks like cos. So if dy, if y is equal to sine x, dy by dx is cos x. Okay, if you differentiate sine, you get cos. Okay, doing the same thing for cos x, you know you've got a station point at the start. It's not that obvious when you just draw the graph, but you know that it comes back down at that point. So you've got a station point at the start, then it's negative until the middle. Okay, at that point you've got another station point at 180. It's positive all the way to the end, and then you've got another stationary point at the end at 360. So the stationary point at the start, the stationary point in the middle, and stationary point at the end. Okay, so we should have roots at 0, 180, and 360. First part's negative, so it should all be in here. The second part's positive, so it should all be in there. And when you do your derived graph of that, it goes, it turns, it comes back up, it turns again, it comes back down. Again, awfully messy. Okay, but I'm hoping you can see again that when you differentiate cos x, when you do the derived graph of cos x, you end up with an upside down sine graph. So for cos x is your function, dy by dx is minus sine x. Okay, and looking at that, that is the rules. When you differentiate sine x, you get cos x. When you differentiate cos x, you get minus sine x. Okay, so looking at just two quick examples. When f of x is equal to 9 sine x minus 3 cos x, we'll differentiate in sine, we get cos. So 9 sine x just becomes, when we do the differential, 9 cos x. Cos x differentiates to minus sine, so that minus 3 cos x is going to turn to positive 3 sine x. Okay, that f of x is fine to differentiate for the cos and the sine, but that cubed root of x at the end is a problem, so it's 4 cos x minus 5 sine x plus 6x to the power of a third. Bit messy there, sorry. Which means your differential, 4 cos x, we know cos x goes to minus sine, so that would be minus 4 sine x, minus 5 sine x just becomes cos, so that would be minus 5 cos x, and then this just differentiates as normal, a third times 6 is 2, and decrease your power by 1, it will be minus 2 thirds. Okay, you can rearrange that back to roots and powers and so on. Okay, but the important thing here is that you guys know how to differentiate in terms of the form y equals a sine x. Sine becomes cos, and being able to differentiate in terms of the form y equals b cos x. So cos x becomes negative sine. Okay, thank you very much.